Hello, everybody. Good morning. Everyone having a nice icy Saturday? Seem to have missed out on all of the snow, but I'm sure everyone's plane was still canceled. So this is the Outside the Equation Exploring Alternative Forms of Mathematical Communications panel. I am your host, moderator. I'm a podcaster. I'm your host. This is Relatively Prime, communicating in the mathematical domain. I am Samuel Hansen. And again, I bring to you excerpts from a panel at this past January's joint mathematics meeting in Atlanta, Georgia. This time around, it was all about diverse and unique methods of communicating mathematics. I see no reason to beat around the bush here, though, because I already introduced this very well a few months ago. So let's get right to it. With me today, I have Haensch, Tim Chartier, and Robert Schneider, all of whom will now do a short introduction where they tell you a little bit about themselves and a little bit about their alternative form of mathematical communication. We are, of course, talking outside of, your typical writing and lecturing communication, which is what most people do in order to communicate mathematics.
Thanks, Samuel. Thanks to everyone for being here this morning. So my name is Haensch, and I am an assistant professor at Duquesne University, which is in Pittsburgh, Pennsylvania. And I host a podcast. And when I podcast, I always begin my podcast by saying that. And it's always the most difficult part of the podcast. I always have to say it like 12 times. Hello, my name is Haensch. I'm an assistant professor at Duquesne University in Pittsburgh, Pennsylvania. It's incredibly difficult. And then I start laughing in the middle.
As the editor of her podcast, I will say that that's entirely true.
So I started podcasting about 2 years ago. And I do this podcast with my best friend who I met in graduate school. And we decided to do it because we were often talking on the phone for great lengths of time. And we realized that we would start to talk about math quite often, and not necessarily math in the Galois theory sense, but math in the sense of applying kind of mathematical logic to real life problems. Using this kind of funny mathematical language to talk about relationships. Like when I'm saying, "Oh, I'm so mad at this person. I just hate them," and she would say, "Well, don't you think that maybe you're almost approaching the point at infinity, that perhaps you're going to love them soon?" And it was just realizing we had these really rich, nice conversations. And then we thought, we're enjoying them so much. We should record them so other people can enjoy them too. And then we had the good fortune of meeting Samuel, who thought we should do that as well. So we tried to record as often as possible, but life being as it is, we're quite busy. So we have this podcast. It's called The Other Half. And the point of it is to talk about life just as such and apply ideas of mathematics to life. So we've podcasted about the weather, traffic, kind of mundane things. And my favorite one by far was we did a podcast about racism and segregation and how you can understand the ill impacts of racism and segregation by looking at it through a mathematical framework. So it's in its essence, it's just conversations about life as you would have them with your best friend, but trying to understand them as a mathematician.
Great, I'm Tim Chartier, and there are probably several things that are rather untraditional about the way I communicate math, but probably the most dominant one is through movement, in particular mime. And so sometimes people wonder why did we choose to merge mime and math? People have enough stigma with math that we decided to combine that with the stigma of mime. And so we just hoped that it was kind of a multiplicative thing where the negative and the negative became positive. But one of the things that I think is true of both of them is that people often think that they don't like math. I don't like it at all. I have no good story to tell of math. I'm bringing my child and it's mime and math, so I'll sit here with my phone and do whatever while my child enjoys this. For a lot of people, when they experience math in a refreshing way, it truly is like getting a drink when you're completely parched. They've had a parched life in their mathematical experiences, and suddenly they don't. And through the art of mime and being visual, people are able to see that maybe the reason that you don't like math is because you haven't experienced the math that fits the way you think. Maybe you're a visual thinker. Maybe you would be good at math and topology, or maybe geometry that isn't high school geometry like you learned it. And it opens people up to hear things and see things in new ways, even if we're not teaching mathematics. Occasionally people will say, you're not doing math. I usually don't argue that, not simply because I'm a mime and don't want to, but that's just its own argument that's separate. To me, that's just showing that person's preference. But to say that it's not math, to me, is always an intriguing argument, because many of the ideas I use over and over again in class. In fact, half the show that we'll do today as part of, I don't know how to say it, the Mathematicon or whatever it's called, are sketches designed specifically for class. They were not designed for performance per se, and they became so in time. So for us, mime is a way of moving beyond the words so that people can enjoy and be introduced to the concepts themselves. And as is inherent in art, you can see what it is that you are open and ready to see, which sometimes I don't think we may in this room, but I think as at least a society, we sometimes think we're supposed to see what we're supposed to see. And math can be much richer than that. And mime is a venue that can underscore that there's that part of mathematics as well.
Hi guys, my name is Robert Schneider, and I'm a graduate student in number theory at Emory University here in Atlanta. I came to mathematics from being a musician. I've been a musician and a record producer and a composer for most of my adult life up until a few years ago when I went to graduate school. I dropped out of college when I was about 20 as a senior in philosophy, and at that time I had never taken a college-level math class. I started to take those when I was in my late 30s, but luckily I was already a senior, so that was convenient. I see mathematics and music as being very similar. Obviously there's a lot of mathematical components to music and to the theory of acoustics that are incredibly interesting on their own, and also theoretically interesting to music theory. But, it's like, who are we as people? We're like minds, and we think things and we feel things and we feel a need to communicate these things. And we want to transfer our thoughts to other people and we want to get those thoughts back. And like visual art or music, mathematics is sort of a non-verbal language that expresses ideas and emotions, just like language does, but it expresses them in a different way and in a fairly subtle way. And in mathematics, much like music theory, there's a terse language that's incredibly more varied than music theory. That sort of, allows you to represent on paper your ideas, but those aren't the real ideas. The ideas are these huge things that are hovering around the paper, just like a symphony hovers around the score. And my interest in expressing mathematics through music is not coming from the perspective of a mathematician, because I come to mathematics from the arts. For me, it's a creative, enjoyable act, as it is for everybody. Obviously, but that's my interest in it is mainly in that, as opposed to its usefulness or its truth. To me, it's about beauty and sort of mystery, like art. And for me as a composer in music, I am interested in exploring different sounds and combinations and patterns that haven't been heard before. Our brains and our ears and physical objects resonate readily with, for instance, chromatic scales, things, Pythagoras basically discovered music theory as we understand it, in its simplest form. But yet, there are so many possibilities with sound, of ways to combine sounds and to express feelings through them. So my interest, I suppose, in using mathematics is in composing using patterns and ideas that haven't been heard before, that might create new brain, neural connections and maybe new ideas in the listener, and that can allow me as a composer to feel different feelings that I haven't felt before, and then to try to stimulate those in listeners. So I guess for me, I love to use mathematics and try to find ideas in math to, explore and then transmit these different ideas and sounds. For example, I kind of came into the math community exactly 10 years ago because I was invited to speak at Math Fest. I was on tour in Europe with my band, and I had that year sort of been experimenting with a musical scale based on logarithms. You can basically just tune the notes of the scale to the logarithms of whole numbers. The notes get closer together as the logarithms do. But due to the special properties of logarithms, the log of xy equals log x plus log y and so on, I had realized that there are things in music called beat frequencies that I don't necessarily need to go into right now, but these are aspects of the timbre of sounds that we hear when we play chords or when we strike instruments. And when you tune your musical scale to logarithms, the chords, when you play them, produce beat frequencies that are also connected by the properties of logarithms to the scale you're playing. They're not these random sorts of like overtones or, like random timbres and stuff. So there's a really weird organized sound that happens when you play chords with notes that are tuned to logarithms. If you look at it on an oscilloscope, for instance, you play a tone, and on an oscilloscope you'll see a sort of a vibration. If you play two tones, that vibration becomes more organized. And with the logarithmic scale, if you play 2 or 3 tones together, for instance, I found a very nice chord, and as I played one note, it was like oscillations. As I played the second note, it turned into a circle, which wasn't surprising because oscilloscopes track phase and stuff. When I played the third note, there was suddenly this 3-dimensional knot that appeared on this oscilloscope. It looked like crazy, like 1980s, vector computer graphics from some, awesome Atari game or something. Not only did it form a beautiful knot shape, but the knot was rotating in 3 dimensions on the oscilloscope screen. It was a beautiful, amazing shape that came because the logarithmic properties of the chord canceled out all of the stray overtones and stuff like that. And there was just this beautiful shape left that was tracked on the screen. This was a beautiful experience for me. In general, I think it's interesting and fun and beautiful to explore different sounds and different feelings. And mathematics has this whole library. It's not even a library, it's a universe of patterns that are not really accessible through any other means but going into the universe. You can't just like look into mathematics and really get what's going on. You do it, just like, you feel it and you manipulate it and you interact with it. You can bring those through other media and in at least a small way allow those ideas to resonate with others by using the arts and literature and other media to express mathematical ideas. And so to me as an artist, and I think for artists in general, it's a rich catalog of patterns and new feelings that can be expressed to the public and to the listener and to our friends and just, even for ourselves. And that's my interest in mathematics crossed with music.
One of the things I usually wonder about when talking about these alternative forms is the sort of different reactions that we get with these alternative forms versus the reactions we get when we're, say, writing an article or giving a talk. Did anyone have an example of where they got a pretty different reaction from their audience because of this different way that they are communicating, or maybe they're able to communicate to a different group of people than we normally would when we're just up there giving a fun math talk?
Well, I'm going to tell a funny story, and then that'll give the other panelists the time to think. I'm not this answered what I thought you were asking until you finished it. So
No, it's as long as it's a more interesting question than the one I actually asked, it's fine.
So because it's mime and math, the introductions can be quite intriguing when people decide to introduce the show. And I was invited to a particular school, and they typically would get 100 people at that type of venue, but because this was mimatics, as we call it, they decided to invite and push it in the radio to the whole community. So schools showed up, and the entire auditorium was packed with 350 people in the seating and all the walls lined up. So the person who had organized it was like almost intoxicated with just the experience of having that many people there. And so when he got up, I think, like, if you see students do this, where you see their mind go blank, and he walked up to the microphone, saw all the faces, and then I saw his mind just go, and it was like, oh no, I don't know what's gonna come out now. So he said, we've never seen Tim Chartier do any of what he's about to do, but we figured anyone who was bold enough to do mime and math together, we just had to see. Let's welcome Tim Chartier. And so I do a lot of performing with my wife, and we were doing professional performing prior to the mimatics that people see now. And we have trained with Marcel Marceau and so forth. And so we're doing it very seriously. And that's fine. I mean, there are many hills you climb when in performing that you just get used to. But when I told Tanya the story, she said, my goodness, what did you do? And I laughed, and I said, what do you think I would do? And Tanya said, you went up there, and for 10 minutes, you basically did almost stand-up comedy to get them, we call it in the room. to get them in the room? And I said, yes. And even worse, I learned later that 50 of the people out there were required to be there by their teacher, which I could see because there was this group that were sitting together with their arms crossed. And then he gave that introduction, and then their shoulders got tight. And I thought, oh my goodness, I don't know how I'm going to get them in. So what I did was there's many ways to do mime where it's almost like you're your own prop, but almost like prop comedy, and you just do funny things for people. And I was doing all that, and then suddenly, if this makes any sense, the room relaxed, people were there, and then I could say, now let's talk about mime and math. And people stayed in the moment. And then we had a delightful time. It was just a delightful show. But sometimes, because it's alternative, it's in itself unknown. And so there's that unknown factor that example was just the introduction. Other times it has nothing to do with the introduction. It's just the nature of the art itself, is that we always think, what's the first thing we're doing? Because we don't know what the room will be like.
People have a preconceived notion of what it's going to be, like mathematical content is going to be dull. Oh, it's not for me. You're pairing it with miming. I'm pairing it with audio, which doesn't seem to sit well with math. So you are up against this wall of like, oh, no, that's not for me. But it's been such a really fun experience to release this product and have people like it who had no idea that they would. Because we're kind of talking about things that you would talk about anyways. And people have this idea that math is equations and numbers and this kind of dull stuff, quadratic formulas, and not things that you would ever see in your life. So just having a casual conversation with your girlfriend about this or that, and then suddenly realizing 20 minutes later, oh, we've been talking about math the whole time. It's particularly people who I know who have this like extreme math aversion, to show it to them and have them come back and say, oh, I really like that. That's math? Oh, well, I guess I like math then. Okay. It's really nice. So that's been my favorite thing. I think that answers your question.
Yeah.
So I think I need to speak in a slightly larger sense about the effect of mathematics and music on people that I've observed outside of my own. Because we're talking like me sitting with two friends and like playing some chords and them going, oh, it makes my stomach feel kind of funny or something like that. You know, it's not like a public response. And that happened. I think, for instance, there's a composer named Lamont Young. And Lamont Young is a mid-20th century composer. He's currently a composer, but he started composing in the mid-20th century. Lamont Young, well, his philosophy is that sound evolves over time in the air and in space and in the listener. And sounds should be extended for a period of time to allow you to really taste them, let them soak in. And so he writes about this stuff, and he talks about how music is just chopping the sound up into all these little islands of sound and taking away the most beautiful property of it. He's basically saying like rhythm and melody are bad, and like, which is like crazy. I mean, it's not crazy. It's really, really just different and futuristic. So anyway, his composition, The Dream House, is a chord of about 37 or 38 sine waves that are all co-primed to each other in wavelength. And they're tuned to prime numbered wavelengths in some way, or maybe prime numbered frequencies, actually. And because of that, he sets up these standing waves in the room, and the standing waves give a spatialization to the sound. You can walk through it and feel the sound in your body, and the sound is different at every point in space due to the coprimality of all the waveforms that are bouncing around in the room. He sets it up in a very scientific, acoustically optimized way. Some people hate this. I mean, how could you not hate it if you walk into a room? It sounds like you're inside a machine suddenly. I think most people, however, if you just didn't run out right away, it sinks in, and there's this profound effect that really does make you appreciate the extended tones that the composer's into. But very few people would listen to something like this. On the other hand, like Bach used mathematical structures in his compositions with great effect and with great popularity. So it's not like it always turns people off. I think it depends on how well it fits into the current kind of, just the vibe of your time. On the other hand, you have a composer like Xenakis, who was an orchestral composer in the 20th century, who turned to music from mathematics and architecture. His compositions are fairly popular and highly influential in classical music, but you're certainly not like hearing them at Christmas time. They sound like an army of like groaning, kind of like maybe like if a whole zoo decided to sing at once or something. His scores look like geometric diagrams all over a page, and at the end of every line it says cello or clarinet 2. It's like the musician is supposed to look at the sprawling drawing. It looks like an architectural diagram, but it's highly abstract, and play it as a score. He's sort of like what I would consider to be in the middle of upsetting people's stomachs. Although when ideas like this have been introduced into music, it's famously so that the audiences, at least upon the first listening, will hate it. I think that expressing mathematics in music, the farther you go from the standard music of your time, in any direction, never mind mathematical, people are less likely to listen to it. So I don't see that, say, for instance, putting math into music is extremely different from doing experimental music or noise or free jazz or something like that. On the other hand, if you get into it in the right mindset and you're following the composer, like Lamont Young's installation, you have the opportunity to tune into this different idea and to really feel it in a different way. And I think that when people do that and they take the time to do it, it really does resonate. You don't have to understand the mathematics to feel the mathematics in a musical way. I guess does that address that well enough? I mean, like, it's just like, my only experiences have been on a really small scale because I've released this music on a wide scale, but it's not like it's extremely esoteric. I'm sure people hit skip on the CD to the next song. Or hopefully they don't.
One of the most interesting differences between doing mime and math and doing mime strictly on its own accord is that when we do the mime just as its own art form, we do whatever we want to do. We perform things that we think up and then we perform them. One of the most interesting things about mimetics is that we want it to hold for the artists in our life, that there was this period of time where no one knew that I was studying math at all. When I taught and performed in international performing arts conferences, even when we performed for Marceau, he thought we were full-time performers. Nobody knew. It wasn't like I was hiding it, but they're rather generally math-phobic folks, so it's not necessarily something I want to go and have a discussion about either, so we just didn't talk about it. So I want them to come and see the Tim and Tanya that they know, if that makes any sense, the artists that they know, that we didn't just like change what we do because we got to figure out a way to do it with math. That just doesn't sit right with us. But then on the other end, I want a mathematician who knows me only as a mathematician, and when I say that I'm a professionally trained mime, goes, what? Yeah, you are rather lyrical in the way you move. They don't say it like that, but you need both. It needs to be mathematically correct, which to the artist is not necessarily the case. I've had many of my artistic friends go, well, why don't you just do that? It'd be great. I'm like, because it's mathematically wrong. And they're like, so? And I'm like, no. I mean, if the sketch is about being mathematically wrong, that's fine. But I'm not going to the JMM and doing that. So, and then on the math side, it's like, I've got the best idea for you. Okay. And they share it, and Tanya and I use the language, it's not mimeable, at least yet. That's cool, but I don't really know how people be watching for very long. I mean, you would, but I mean, I don't know how to make it. Mime is supposed to extend beyond the words. In a musical, people sing because they'd never say that. Their emotion is so elevated that they're now singing. Mime is supposed to be that you actually don't realize we're not speaking, except at the beginning because you're not used to that experience. But once you just sink slightly in, you don't notice that we're not playing charades. You're not trying to guess what I'm trying to say. This is the only way I'd say it. As Marceau would say, if you said anything, the experience would be less. And that's what you're shooting for. Well, we have that in math, where we write or we look or there's those moments beyond words that the prof may say something, but none of us are listening because of those profound moments, the moments that we see that knot, that three-dimensional knot go on the screen. There are, for me too, it was the artistry of math that pulled me in. I was definitely not a math major. It was my backup. And then I hit mathematical proofs. And it was the day that there were two sizes of infinity, let alone what came after that. That was the day I went, wait a minute, this has a place for me. Because up to then, I kept assuming one of these days I'm tapping out. I don't know why, but I'm just so different. And I said to someone last night, I was way more artistic in my general just way of behaving than I am now. And the person went, really? And Tanya went, oh yeah. And in terms of where that is, because of the reason that came to mind with your question, Samuel, is that in that sense, mimetics isn't that different from what we did before. However, there are versions of mime that I've yet to figure out how to put in to mimetics. I can't, it drives me nuts because we'll do our normal performing and these rich sets of mime come out that we perform. And people who come to that who know mimetics go, man, you should do that with mime and math. It's like, I know, but I don't know what mathematical idea to do. I can't wrap my head around it yet. Or I know what it is, but I don't know if I can adhere to the math while I'm doing it because it's so artistic that I haven't gotten my brain to think that if that makes any sense. Like, I'll take too much artistic license with it at this particular time. So it takes time for those things. The ideas grow, and these are in infant stages, and some of them will be infants forever. They don't have to grow up. But the thing that I love is when we go to particularly universities, and you have professors sitting with their families, particularly the children who are not the math lovers, and they sit and they point, and they talk, and they giggle, and they share, even though it's like a Pixar film, not that I'm at the level of Pixar, but like in Pixar, where you're both laughing, but not necessarily at the same thing, and yet at the same thing. And when that happens, for me, that's a very special thing, because I think that that is definitely there in mathematics. And when we can do that, it's very special. Just like last night at Colin Adams' performance, where my daughter would turn, she's 10, and would be laughing at this sketch that I'm laughing at because I'm a professor. And she's laughing at because I don't know why. I'm thinking, why is that funny? You know what I mean? But it doesn't matter because it transcends both of us at this other part. And that's what makes podcasts beautiful. That's what makes music beautiful, because those experiences are so different than what I do that allows me to enter math for myself in a new way as well.
So in order to give something the mathematically perfect definition or theorem or something like that can oftentimes include all of this language and things that a lot of people don't necessarily have. And so there's that perfect from the book version of math, and then there's the version that you can give to the public that will let them understand almost all of it, but not necessarily all of it. And I was wondering if y'all could talk a little bit about how you will approach like taking one of those harder problems and modifying it just enough that you feel mathematically comfortable using it, but that it's not necessarily the whole thing.
I was the AAAS Mass Media Fellow in 2013, and I was working at the science desk at National Public Radio in Washington, D.C., which was fantastic. And while I was there, I was kind of a mathematical quality control consultant to science stories. So people would have me like double check their arithmetic on their science stories. And occasionally I was able to write a mathematical story for the air. This happened very, very rarely. And I was always really excited when I got to write a math story for the air, because there are so precious few mathematical stories on the radio. I mean, it's possible that maybe you've never heard one. I would say there's maybe one a year. So I was so excited when I was asked to write a story that was somehow loosely related to the Poincare conjecture. Of course, I had to make this palatable to a radio audience. I had to kind of buff down the edges to make it something that you can talk about without any visual aids, and that people aren't just going to tune out immediately. So I wrote some little story about holes in things and surfaces and this and that, and it was maybe a 45-second spot on All Things Considered. And I was really excited about it. I wrote it with Joe Palca, who's a fantastic science journalist, and I felt like I was doing the right thing for my profession, somehow getting math on the air. And I was just really amped about it. It went up that evening, like on the commute home time, whenever All Things Considered is on. And the next day, I came into work to heaps of hate mail from mathematicians, which boggled my mind. Heaps, not heaps, but at least 5 emails had been sent to the editor on my desk saying that I had inaccurately represented the Poincare conjecture, and you forgot this part, and you didn't mention the higher dimensional this and that. And it just made me so mystified when I thought, like, here I am, a mathematician, putting math on the air for you, and it's exactly the mathematicians who are kind of wagging their finger at me. So this has been something that I took that to heart, and I think about it often when I was working at NPR, now when I podcast, and when I write my blog, about where it's safe to kind of file down the edges and where it's not. And I wish that as a community somehow, we could be a little bit more understanding of what it takes to bring math to the people. That as a community, you can't give a fully formulated theorem with supporting technical lemmas and multi-page hypotheses and expect anyone to care. They simply won't. I know we do, but we're good like that. That's just something that I think about, and I don't like to call it lying, but in my mind I do. I think, is it okay for me to lie on this? Is it okay for me to kind of just file down the edge just a little bit, just so it's a little easier to swallow.
I think that it's really unfair that a bunch of mathematicians wrote about your story, because if you want to read the news story about that result, you have to read the paper. That is the news article that contains all the details. It's not like, something coming off of The Wire and it's got all the details in it and you have some standard journalistic way to write it. It's like, seriously, like, if you want to read the story, you have to read the article. And that is the news story. All you're doing is giving the headline, basically. And the headline for a math story happens to be 45 seconds long. It's a really long headline. But it's a long article, presumably. I think that part of the issue is that if you have an idea you want to express to somebody, you have to talk to them in their language. You can't go up to somebody that speaks Spanish and start speaking German to them. And I think that no matter how deeply you feel the idea, you have to speak it in the way that the person's going to understand it. So I think that what you call lying, it's appropriate because we all learn a little math, like we're like little kids and we learn to write and draw and we learn a little about music and we learn a little about math. And maybe some people go on and they're poets with their language skills, or they're artists with their drawing that they learned, or they become musicians having learned to play the xylophone or whatever as a child, but far fewer people go on and do mathematics just as a hobby. There's not a venue for it. It's not like you can join the math group at your church or something like that. Like you can join the choir, you know what I mean? It's like it's a rarefied but still comparable medium, and it's something we all learn as children, but our skills stop with mathematics. Our skills stop where it's useful. You stop learning math at the point that it gets more esoteric. So that's why there's this misconception about math. Oh, well, it's just this boring, useful stuff. Well, yeah, it is boring and useful, just like when you learn grammar. It's just that you mastered grammar way earlier and you're able to start reading literature in middle school. In mathematics, you can't read literature until you get into, say, your sophomore year of college or something, unless you're really, really motivated. So you don't have the exposure to these bigger ideas because you stop learning at the point. It's as if you stopped learning about poetry because you didn't like learning grammar. And I think that, I'm not trying to argue the point. All I'm saying is that most people are able to go into poetry and go into art to some degree and go into things like music in their schools or their orchestras or their churches or rock bands. And most people aren't able to push through at the right age to get into the comparable kind of realm of mathematics that's more like literature or playing music or something. But that language is there in everybody. Everybody has the same very basic childhood skills in math and art and language and music and so on. You can talk to anybody about these subjects if you're able to allow those memories and those early experiences and those early lessons to resonate. And so I think that in math, it's not a successful way probably to talk to the public unless you're able to speak a language that will resonate with the most people. And so I think that being able to pull in public performance and to pull in humor and to pull in storytelling and to tie it to art, not just to make art, but to actually just be able to to talk about it in a way that people can be like, oh, I get that. You can be like, okay, well, the math is really abstract, but, think about cubism, Cubism, and it's kind of like that. Cubism doesn't look like the thing they're painting, but it's beautiful because of just the shapes, and math's like that. Or, I'm just trying to say that I feel that it's important to address people in the language they speak, and most people share a basic language in the arts as well as in math. And I think that these all tie together in early memories, and you can stimulate the math feeling by stimulating the other feelings around them. So if you talk about history and stories and music and things like that, I think that helps prime the mathematical sort of ideas to kind of emerge in people where they have kind of become dormant. So for me, even in writing a math paper, it would be nice to have a math paper where at least like the first 2 sentences your mom could read and be like, oh, that was nice, or something like that. You know what I mean? It was nice, and then I didn't understand it. But I think it's good to try to be friendly and to try to stimulate the more sensory sorts of memories and feelings in people when you can. And I would think that is why the mathematicians were off base, because you were doing the right thing.
One of the things we often say in a show is that mime is just our communication style. This is the way we communicate math. If that's been special for you, what is your way? What are your interests? Find that, and that may be the connection that can either deepen your experience with math or give you the experience that maybe you didn't even know you were searching for.
Before I ask the next question, everyone here has probably seen that there's some sort of weird thing next to Robert over there, and we haven't had a chance to hear it yet. So he does have a marimba.
Yes. So I had mentioned earlier about the musical scale tuned to logarithms, and I have like this marimba, which is an African thumb piano, and it's an instrument. It's really hard to a musical scale that's tuned to a mathematical sequence it doesn't line up with any of the normal notes, right? The intervals are different. It's not like you can pick out a subset of notes on the piano and play the scale when it's an alternative scale. That makes it really hard to compose or play for it. I mean, it's really I used a sine wave generator, literally a tone generator to generate tones for my compositions, because that was the only way I could think to do it. There are a few instruments that it's easy to use to play an alternative scale. And the thumb piano is a really great one. It's simple, it's easy to get, and you can slide these little bars. It makes a sound. It makes a sonorous, non-clunky sound. I'm joking, but but you can slide the little bars back and forth to tune them. So I took my tone generator and I tuned each bar, and I made little pencil marks on them where they needed to line up when they inevitably fall out of place. And so I can compose kind of just sitting around if I want to in this musical scale on my thumb piano. I had a composition I wrote last year while I was on the beach, but I don't think I can remember it, but I'm going to try to remember a few chords of it. But also I'm just going to play through the scale so you can hear what I mean when I talk about a scale that's an alternative scale. Is that cool? Okay. This isn't it's going to sound awesome. It's going to sound terrible. I'm not saying the scale's terrible, but it's going to sound terrible to you on this thumb piano. So this is the 1 octave of a scale that's tuned to logarithms. It starts at log 4, log 5, and so on. And these are the frequencies that are tuned to that, okay? So the notes get closer together because the logarithms get closer together. So those notes, it starts out sounding kind of similar to the regular scale. Kind of starts to go off because the logarithms are spaced quite nicely at the bottom of the scale. They sound musical, even by our standard feeling for music. But at the top of the scale, you get sequences like this. They're almost microtonal, and so these are tones that are much closer together than what we normally hear in a musical scale. Our brain, when you hear something like this, your brain just it stretches. It wants those notes to get pushed up to the ones that you're used to hearing. Those notes, they're not just vibrations in the air. I mean, our brains actually our neurons fire off at the rates that we hear these notes. They want to hear your brain wants to hear the notes sound right, okay? But they don't. It's a different kind of scale. The first time I played it, when I was able to transfer it to a synthesizer keyboard, it was the weirdest experience because I'm so used to the keyboard sequence of notes as a musician and a songwriter. And when I played it, it was I said to my wife the first time I tried it, it's like my mother turned around and spoke to me with a man's voice. It was so shocking and strange, and but in any event, you can pick out subsets of the scale where there are these beautiful harmonies that are, in a sense, they're more sonorous than the standard harmonies because their overtones and their timbres are also part of the scale, which isn't possible with the standard tuning. For instance, I'm going to try to pick out a few chords. Notice how if I change from this chord to this chord, There's hardly any difference in the notes. For instance, this note to this note, they're very close together, or this note to this note. They're almost the same, right? Now, but hear it in a chord. That sounds pretty nice. Now let's try the one that's right next to it. I mean, it's almost the same note. It sounds kind of sour or something like that. And they're just right next to each other, but you hear this ugliness or this niceness. The niceness, when you can get it, it's very, very nice. That's a chord you've never heard before, I presume. But then something like this, that's a chord you don't want to ever hear again, probably. So, there's some art to try to compose at a new scale. But anyway, I'm sorry that I don't have a well-practiced composition to play, but it's really hard to compose and play in alternate scales and then later remember what you did because you're not used to thinking about it.
I have one last question, and depending on how long everyone's answers are, we might be able to get one or two from y'all. And that is, when have you failed with your alternative communication style?
I can answer that. Coming from the arts, my alternative communication style is mathematics. And I'm in graduate school. And so I'm just hoping that failure is not ahead of me. So that's...
I feel like it's hard to pinpoint one time.
What, because everything has gone off so well, or because there's been so many failures?
Well, I feel like the good ones really stand out, and then the bad ones you just kind of repress.
I don't really like to think of anything as success or failure. They're just part of the journey. And if you think of, I often talk about, if you think of things as failure, then you don't necessarily thinking of them as, most of your successes come from those times that were challenging. So I don't know, but and it's not quite what you're asking, but
yeah, I'll agree with that entirely. Yeah. I've almost everything good I've ever done happened because I failed at trying to do. To me, failure just isn't a bad word. It's just failure is just something you tried, it didn't work, and then you tried it again and again and again until it did. And they're the things that always taught me the most are the failures.
And one of the things in mime is we're developing new sketches right now, and the first time we do it, it's not people's favorite sketch. So we will very intentionally place it between two much stronger sketches so that people aren't like, whoa, what happened to this show? And as an artist, I have to try new things. And I remember the first time I saw Marceau do new material, and it wasn't that great. And it was fun, but it didn't have the depth and the robustness of the other sketches. And Tanya and I turned to each other and went, wow, his sketches grow up too. And so sometimes they're failing because they're learning to walk in the sketch itself. And other times just because it's just not a good idea. But, I'll tell you, I know the time I had the worst bomb ever. That was hilarious. Yeah, I knew I'd think of one. All right, so I was asked to perform at a Renaissance festival. And so I'm a stage performer. I'm not a street performer at all. And you do mime, I know, but you train in these things, how to get an audience, how to keep an audience. I don't know how to do that. You sit down and now you're in my audience. So they said, well, you come and you'll be on stage. Yeah, sure. And so I get there and they say, okay, well, we're going to put you on this little pagoda. And so it was this circle thing with no room. And I was like, oh my goodness. And then I was at the entrance and it was high school days, 10,000 high schoolers descending on this place, walking in. Well, they're walking in and they're all cool, thinking that, somehow the rest of all these high schoolers are looking at them, just measuring their coolness. But whatever, that's what you do. So they're moving in and I'm thinking, what in the world am I going to do to get them to look at me? Because it's basically street performing. And so I decide that I will just do highly stylized movement and then move into just illusions. Because people will stop for that. If it's stylized enough, you look weird enough that you'll look. Because what is that? And then if the illusion's strong enough, they'll stop because there's nothing there. And that's just really good illusion work. It is captivating. So I just started with that. And then I had 100 to 150 kids standing there. I was like, there we go. And I was brought to do mime and math specifically. That's what they wanted, not mime. They wanted mime and math. So I totally had them with the mime. I was like, man, awesome. Marceau would be proud, although he doesn't like street performing. But nonetheless, he'd be proud because I used lyricism and all these techniques to do it. And then I go, how does this relate to math? So I had 150 people, 145 walked away. Like literally, how does this relate? I mean, it was like, everything I know to keep people engaged. And then 5 students were standing there going, yeah? So then I did it for them. We had a really nice, intimate experience with the infinite rope and and I asked them the questions. But I don't know. I mean, it just wasn't the venue for that. So that was the best I could do in that venue. And as the day went on, I did less math and did just more mime, and because I didn't know what else to do. And so someone else maybe could have done it, and I would have enjoyed seeing them do it. But with my skill set, that was the best I could do. It's a great story. So I'm glad it happened.
Do we have questions from the audience?
So I have a question. How often, for each of you individually, do you feel like you start by thinking of a mathematical concept and then you'd like to have a way to express it? And how often are you just doing something and you think, oh, there's probably some mathematics behind this that I should incorporate?
I can tell you very precisely about the evolution of our creative process. So my co-host Annie and I, the way it goes is one of us will be reading the news or seeing an article, and we'll call the other and say, oh my gosh, did you see this article about such and such? Go read it. And we'll read it, and then we'll call each other back and we'll start talking about it. And it would be an article about patent law or whatever the thing is. And we start having a conversation about it. The conversation gets a little bit mathematical, and then we say, wait, stop. I don't want to hear you right now. We need to turn the microphones on. I want it to be a surprise. and then we set up the microphones, and then we start talking. So it feels, by construction, it's a very organic thing that we're speaking about topics of mathematical flavor that somehow we would have been talking about anyways.
I don't professionally handle microphones at all. Clearly. Thank you all for coming. I want to thank all of my panelists, Robert Schneider, Tim Chartier,
Thank you,
Haensch.
Samuel.
And have a great rest of your day at JMM.
Thank you, guys. Have a great day.
Thanks for coming.
That is all the time that we have for this episode of Relatively Prime. I want to thank my guests, Robert Schneider, Anna Haensch, and Tim Chartier, for a great panel, and the AMS and the MAA for letting me put on this panel at their wonderful joint mathematics meetings. If you haven't been to one, I thoroughly suggest going to the one next year. It's in San Diego. It's going to be a lot of fun. You can meet me, hang out. It'll be great. Relatively Prime is brought to you by its amazing patrons on Patreon. If you want to help support the show like Thomas Fries, John Gamble, and Joyce Lee have, please head over to patreon.com/relprime or go to relprime.com, that's RELPRIME.com, and click support. If you do, you can get access to this whole panel, including a story involving a number system, an editor, and me. This support is the only reason that I can keep making the show, so any help that you can provide is greatly appreciated. The music in this episode was from Supermilk, whom y'all can find on SoundCloud or in the show notes for this episode on relprime.com. If you have any feedback for me or you just want to say hi, reach out. I'm Samuel at acmescience.com. And while I was very glad that Shady Shackle, Josh4737447383, who finds 1 infinity 5 6 3 3 3 3 3 3 3 3 3 and so on, otherwise known as the sequence of the number of regular polytopes in dimensions, and Winsonata, who loves that e to the pi I equals -1, all left me new reviews in Apple Podcasts. I would be even happier if all of you did it too. And if you want to include your favorite equation in that review, I'll be sure to give it a shout out. Reviews are what help bump up the show in the Apple rankings, which are really the best way to get more people to find out about the show. So please help. Please, please, please. Finally, Relatively Prime is licensed with a Creative Commons Attribution Share Alike license. So please feel free to remix my voice to make it say anything you please, really. Whatever you want, as long as you say that those words came from Relatively Prime. Have a matherific week. I know some of you hate that, but I love it.